For the last little bit of this first part of 7.3, we're going to practice reducing some radicals inside of larger fractions, which is a skill you're supposed to know from beginning algebra, but can often throw students, and they need to have the skill for solving quadratic equations. So the first thing I'm going to do is make a note for this first one, which is that if the radical can be found, then you're going to have to find your number of results, which obviously is setting you up for something here, which is that the square root of 9 exists. It's 3, right? So you have to find it. So it's 3 plus or minus, here, hold on, 3 plus or minus 3 over 21. So that means I have to find both answers, right? So there's result number 1. If I could spell the word result. There we go. So that would be 3 minus 3 over 21. That would be 0 over 21, which is 0. So there's answer number 1. Then you have to find answer number 2, which is 3 plus 3. Well, let me copy all that. That'd be 3 plus 3 over 21, which is 6 over 21, which is a fraction. Let's see. 6 is divisible by 3 2 times, and 21 is divisible by 3 7 times. So there are your two results. All right, so now what about this next one over here? So this is 3 plus or minus, well, we can break this down, right? Because the square root of 9 we just learned is 3i, right? I comes from the negative, and 3 comes from the square root of 9. Okay, now you are not done with this. You have to look at this problem and think to yourself, okay, is there a GCF for of 3, 3, and 24? Well, of course there is. It's 3, right? 3 goes into all of those. So you have to think of that number, and then you have to divide it into all these problems. So 3 divided by 3 would be 1. And then you have plus or minus. 1 divided by, or 3 divided by 3 over here makes 1i, but nobody ever writes that. They just write I. And 24 divided by 3 is 8. So then you divide all coefficients by the GCF, right? That's your tactic here, right? So you can't just divide the first 3 by 3. You have to divide this 3 by 3, this second 3 by 3, and this 24 by 3. All right, now what about this problem right here? -4 plus or minus the square root of 40. That's -4 plus or minus. Now we got to break 40 down. 40 is 4 times 10 over 2. And that's -4 plus or minus. And then the square root of 4 is 2. So find that. 2 square root of 10 over 2. And again, look at your GCF. What goes into 4, 2, and 2? Okay, let me write that down. GCF of 4, 2, 2 equals 2. So what you're kind of doing is basically factoring out 2 from the numerator and then canceling, if you want to think of it that way, or dividing. Or you can think of it this way. 4 divided by 2 gets you 2, plus or minus. And then 2 divided by 2 gets you 1. So it's 1 square root of 10. But again, we don't really write 1 when it's multiplied like that. We just write square root of 10. Or another way to think of it is that you're dividing everything by 2. 4 divided by 2 is 2. 2 divided by 2 is 1. 2 divided by 2 is 1. So really the whole thing is over 1, but nobody would ever write it that way, right? Because we're too lazy for that. Oops, I had to press return there to kind of get it to all fit. All right, so next, -4 plus or minus the square root of 160. Okay, so that is -4 plus or minus And now we got to take the I out, and then square is 160. We got to break that down. That's 16 times 10, right? Okay, 16 times 10 over 2. Now the square root of 16 is 4. So this is negative 4 plus or minus. Okay, now the square root of 16 is 4, and we tend to write the numbers in front of the I. So you write 4I square root of 10. Not that you can't write I 4 square root of 10, but it's considered very bad form. Right? It doesn't look good. All right, now look at your your three coefficients again. You've got 4, 4, and 2. So 2 goes into all of them, right? So it's 4 divided by 2 is 2, so negative 2 plus or minus. Again, 4 divided by 2 is 2. So write 2, oopsie, not there, you put it up here. 2I square root of 10. And 2 divided by 2 is 1. But again, no mathematician would ever write it that way. We would write it as negative 2 plus or minus 2I square root of 10. We always usually put, not always, but we often put the square root in back just because you don't want the 2I to look like it's under the square root. So we put the number in front, then the letter I if we need to, and then the square root part is what's left. All right, now next one. Negative 8 plus or minus the square root of 1200. Oh, Lord. Okay, so 1200. That's negative 8 plus or minus square root of, I bet you probably would see 100 or 12 times 100, right? Over 40. So 12 times 100 is okay, but think about 12 for a second. 4 goes into that, right? So why not take, instead of 1200, why not take 3 times 400? That would be even better, right? Go for the biggest perfect square you possibly can. So this is negative 8 plus or minus, square root of 400 is 20. So it's 20 square root of 3 over 40. Now you're still not done because 8, 20, and 40 all have a GCF. Let's write it down here. GCF of negative, well, we don't really care about the negative. 8, 20, and 40 would be 4, right? So I'm going to have to take 4 and put it into all three of these numbers. So what's 8 divided by 4? That'd be negative 2, right? Negative 8 divided by 4, excuse me. Plus or minus. 20 divided by 4 is 5, so that's 5 square root of 3. And then 40 divided by 4 would be 8. Now I double check. Look at your coefficients. 2, 5, and 8. Yep, they don't have any more factors that go into all three of them. So we're done right there. All right, last one. Well, hopefully you can spot from a mile away that the last one's going to have an I in it. Because once you see a square root of a negative like that, it's going to be I. All right, so this is negative 4 plus or minus I square root of, all right, now let's take a moment and break down 128. Well, 12 goes into 128 32 times. But then I think to myself, wait a second, 32. 32 is 4, well, actually, it's 16 times 2. So there's something even bigger that goes into 128. So let's try again. How about 64 times 2? There we go. 64 is quite large, and it's a perfect square. So you're always better off going with the biggest perfect square you possibly can. So this is negative 4 plus or minus. Square root of 64 is 8. So 8I square root of 2 over 20. And then that's GCF. 4, 8, and 20 are all divisible by 4. So that's negative 1 plus or minus. 4 goes into 4 once. 4 goes into 8 twice. So you have to put a 2 there. 2I square root of 2. And then 20 divided by 4 would be 5. So let me make a note. GCF of 4, 8, and 20 is 4. Right? So you're dividing everything by 4, and that gets you here. Now here you have to keep writing this 1 here, because if you don't write the 1, then you don't have your first term. Right? I don't bother writing a 1 when it's in the denominator because that's just lazy, right? Oops, cancel. But I do write the 1 and when it's in front because it's its own term right there. All right, so I probably should have made these a little note. That way, that way you see where those are coming from. Other than that, we are all done with this section, and I will see you back here for the next one, which will be, I don't even know. go look at it. What are we doing? Oh, solving with the square root method. All right, so I'll see you back here for that section.